Hey guys, and welcome back. My name is Miss Danielson, and today we're looking at substitution. Now, substituting a cat as a guard dog isn't exactly what I had in mind, but sure, why not? I was thinking more about algebraic substitution, so substituting values into equations, formulas, or expressions, like this example I've got here. Now, I'm a bit dyslexic, but let me know down in the comments if you notice what I was trying to do here. Okay, let's get started. Let's start this lesson off with a bit of vocabulary. I'm hoping you're familiar with these terms, but just in case, you may want to write this down. Variables are the letters or symbols in algebraic expressions, equations, and formulas, which could have any value. You may be used to using the letter x, for example. X is a variable because its value may vary from one situation to another. X is really just a placeholder for some unknown value. So here are a couple of examples. In example 1, x may have a specific value to make this total work out to be 17, while in example 2, x could have a completely different value to make this total equal to 18. We can rearrange these equations to find the value of variables. So for example, in equation 1, I'll get the x on its own. First I'll move the 5 across. The opposite of add is subtract. That's going to be 4x is equal to 12. Then I'll move the 4 across to get the x on its own. Opposite of multiply is divide. And now x on its own I can see is equal to 3. If I wanted to check that, I could substitute the value 3 in for x in this equation. So 4 times 3, 12, plus 5 is 17. So that's solving an equation. And then to check your solution, you could substitute into that equation to see that it works. In example 2, x's value is not necessarily 3. Again, we can work this through, rearranging to get x on its own to find its value. First, I'll take the 6 across. It's adding, so I'll subtract. That means that 3x will be equal to 12. And the opposite of multiplying by 3 is divide. So x must be equal to 4. Here's a perfect example of when the same letter may not always have the same value. It may vary from one question to another. However, variables of the same letter in the same question will represent the same value. And we'll see some examples of that a little bit later. Some more vocabulary for you. Substitution is the act of replacing variables, letters or symbols, with their known values. So if you're told what the value of a letter or symbol is, we just put that number in the place of the letter or the symbol. Expressions is a set of operations to be performed on a set of variables. So for example, do 2 times whatever A is, add that to 3 times whatever B is, and subtract C from there. This is an expression. If I don't know the values of A, B, and C, all I can do is try to simplify that expression, but I can't possibly solve it because I don't know what it's equal to. Equations, on the other hand, we just saw a couple of examples of equations. They are expressions which may be set equal to another expression or a variable or a value, like this example is. 2a plus b is an expression, and there's an equal sign here, so it's set equal to a value of 18. That's what makes this an equation, the fact that it's equal to something. And finally, formulas. They're sets of operations to be performed on a set of variables in order to calculate some specific measure. So these calculations are thought out for a specific purpose, like for example, to calculate a speed or an area or volume or average, etc. So for example, I've got a formula here, and I hope you recognize this formula. What does this formula work out? It's the area of a rectangle. I am sure that you've substituted into formulas before. So for example, our area of a rectangle formula, if you know what the length and width of the rectangle is, you can just multiply them together to work out the area of the rectangle. Here's an example of a rectangle where I'm telling you what the length is and I'm telling you what the width is. We'll substitute those values into the formula. That is, we'll replace the L with 18, we'll replace the W with 5. A is equal to 18 times 5. Now this is a really good habit to get into, using brackets whenever you replace a variable with some value. That way you can see where that number came from. It didn't come out of nowhere, it's inside these brackets. It must be taking the place of the letter that was here before. And the brackets are also really helpful to avoid making positive negative errors. And we'll go over that in a minute as well. So I can now work out what the actual area is if I know the values of the variables in this formula. So 18 times 5, that's 90. And because I know this formula is working out an area, I know what this represents. It's 90 centimeters squared of area because our width was in centimeters and our length was in centimeters. We can also substitute into equations. As we've done before, we can substitute into an equation to see if we have the correct answer, or we can substitute some of the variables that we know and rearrange that equation to find the variables that we don't know. So that involves 3 steps: substitution of what you know, rearranging of the equation, and solving for what you don't know. For example, 3x plus y over 2 is equal to 4z. Now, there's not much I can do about this right now because this is an equation with 3 variables, 3 things I don't know. But if I'm told that x is equal to 6 and z is equal to -2, I can substitute those values into this equation and then rearrange this equation to find out what y is. So x is 6. I've put 6 inside the bracket in the place of the x. You see, if I didn't put these brackets here, you might think I'm saying that this is 36, but 3x means 3 times x, just like 3 in front of a bracket with a 6 inside of it means 3 times 6. So I've got 3 times 6 plus, I don't know what y is, so I've left it as y, over 2 is equal to 4 times, and my z was -2. So I've replaced the z with -2. I put that in brackets. That's not 4 minus 2, it's 4 times -2. So working that through a bit, 3 times 6 is 18, and 4 times -2 is -8, so that's going to be 18 plus y over 2 is equal to -8. And if I want to find out what y is, just like my solving equations that you saw before, I'll rearrange this equation to get y on its own. Right now, y is being added to 18 and then divided by 2. So I'll work backwards, get rid of that divide by 2. Opposite of dividing is multiplying. That's 2 times -18, which is -16. And I then moved the 18 across, which was adding to y. So the opposite of adding 18 is subtracting 18. So y must be equal to -34. I've substituted, I've rearranged, and I solved for the unknown. Here's another example of an equation that we could substitute into. Now these angles form a full turn. So this question actually involves setting up an equation. If this is a full turn, I should know that the angles in a full turn add to 360 degrees. So I can write 2x plus y, that's this top angle up here, plus x plus 40, plus x, plus 2y plus 20. Those 4 angles add together to make a full turn, which is 360 degrees. I can simplify that by grouping like terms. So group my x's together. 2x plus x would be 4x. I'll group my y's together. Y plus 2y will be 3y. And group my numbers together. 40 plus 20 would be 60. Now, I can't solve this equation because there are 2 values that I don't know, x and y. But if I'm told that y is 45, I can substitute that value into the equation. I can rearrange and I can solve to find out what x is. So let's do that. Instead of y, let's put 45. Then we can work that through a bit. So 3 times 45 is 135. Simplifying that by grouping our like terms, 135 is a number term and 60 is a number term. Together that makes 195. Rearranging that to get x on its own. Right now x is being multiplied by 4 and then 195 is added to it. So working backwards, we'll first get rid of that 195. Opposite of add is subtract. And then get the x completely on its own by getting rid of that 4. That 4 is multiplying. The opposite of multiply is divide. 165 divided by 4 is 41.25. So x must be 41.25. Now this is the perfect example of an equation where I've got several variables, but some of them are the same letter, so they represent the same number. All of these x's represents 41.25, and all of these y's represent 45 degrees. So if you wanted to check that answer, you could substitute 41.25 in for all of these x values and 45 in for all of these y values, and it should add up to 360 degrees. Here's an example about substituting into expressions now. Remember, expressions are just a set of calculations. So if you're given the variable values, you can perform those calculations, but don't expect to be able to put some meaning behind that calculation. It's not a formula that works out an area. It's not an equation that gives you the value of a variable. It's just a set of calculations that we are working out. So simplifying as much as possible. So given that A is equal to 0.2, B is equal to negative 0.5, and C is equal to negative 0.1, I'd like to try and work this through mentally because we have been through calculating with positive and negative numbers as well as working with decimal values. So please try to do this without a calculator as much as possible. I'll try to give you the necessary reminders and I'll link the lessons for you down below. So let's work through this expression. 5c plus a plus b squared minus 3bc. It's just an expression. It is not set equal to anything, and we are not told that it will calculate anything in particular. We're just asked to perform these calculations given the values of a, b, and c. So let's start by substituting those values into the expression. So replace the letters with their values. Don't forget to use brackets. That's going to become really important in this example. So I've replaced c with negative 0.1. I replaced a with 0.2. I replaced b with negative 0.5. And again, I've replaced b with negative 0.5 and c with negative 0.1. Let's first go through term by term and see if we can simplify this at all. This here is 5 times negative 0.1. You should remember for a positive times a negative, our answer will be a negative term, and that will be negative 5 times, that's 1/10, so that would be negative 5/10. And the 0.2 or the 2/10 will not change. However, this needs some more thought. This negative 0.5 is being squared. That's negative 5/10 times negative 5/10. Rather than trying to do that mentally, let's actually write that down. It's easier to work this through as fractions, as you should remember from our lesson on square numbers. I'll try to remember to link that down below as well. Next, we've got negative 3 times negative 0.5 times negative 0.1. Again, that would be easier if we worked it through as fractions. That's negative 3 times negative 5/10 times negative 1/10. Now, negative 0.5 plus 0.2, that would be negative 0.3. Then negative 5/10 times the negative 5/10, negative times negative would make positive. And we do top times top, so numerator times numerator is 25, and bottom times bottom, denominator times denominator, that gives us 100. Then we have negative 3 times, let's work out what's inside the bracket before we do the rest. Negative 5 times negative 1 is positive 5, and negative times a negative always makes a positive, and 10 times 10 gives us 100. Working this through again a little bit more, we can convert 25 over 100 into a decimal just by calling it by its place value name. That's 25 hundredths. So this will be negative 0.3 plus 25 hundredths. This is 5 hundredths times negative 3, and negative times a positive is negative, and 3 times 5 is 15, so that's 15 hundredths. I hope you managed to follow through with that mentally. You are allowed to use a calculator if you really must, but remember, if you're practicing for a non-calculator exam as we are, you really need to make your best effort to do as much as you can mentally. Now, we're trying to do this last little bit in our heads. We've got some negative values here and some positive values here. You may want to start by grouping your negative values. Negative 0.3 minus 0.15, that would be negative 0.45. And if I add 0.25 to that, so becoming less negative, think of that as 0.45 minus 0.25, but it's still going to be in the negatives. That'd be 0.2. So negative 0.2. Let's get on to some practice. Here I'm giving you the values of A, B, C, and D, and I want you to use these same values for all of the examples that I'm going to give you below. Work out the value of each of the following expressions. These ones should be fairly straightforward, but you do want to be careful with the positive and negative signs. So remember your rules for that. For questions 5 to 8, remember a number in front of a letter or a letter in front of a letter means that they're being multiplied. And remember, when we're squaring, that means that it is the value multiplied by itself. And it's best to write that out twice, especially when you're dealing with negative numbers. Remember that all values, whether they're positive or negative, will become positive when we square them. Because a positive times a positive becomes a positive. And a negative times a negative also becomes a positive. Go ahead and hit pause now. Copy the questions, show how you have substituted into those expressions your simplification, and hit play when you're ready to check your answers. I hope you had a chance to hit pause, because here come your answers. For question 1, substituting in and simplifying to solve. For question 2, substituting in and simplifying to solve. Question 3, question 4, question 5, question 6, question 7, question 8, question 9. I hope you didn't have a place value problem with that one. 0.2 times 0.2 would be 2/10 times 2/10. That would be 2 times 2 is 4. Over 10 times 10, 100, 4 hundredths. And that simplifies to 14 hundredths. Question 10. Again, I hope you didn't have any place value problems. Go back and check that if you did. Question 11. I hope there were no positive or negative errors here. Question 12. Again, positive and negative errors are a possibility here, and place value. How did you do? Did you manage to do all of that without a calculator? I hope so, but if you needed to use a calculator to check yourself, at this stage, that's all right as well. I hope you found this lesson interesting and it's given you some really helpful reminders. Please let me know down in the comment section if you have any problems or doubts, or if you think I've made any mistakes. That's also possible. Otherwise, just keep practicing, and I'll see you soon.